corrective exercises. So, let's see. Over this presentation, we will be going over a general overview of our project, why is it important, as well as our research question, hypothesis, methodology, and then we'll cap it off with advice for you guys. So, general overview, what is our project? We are comparing two types of resistance training, individual joint and whole leg training, to see which one is the most effective in increasing balance, especially when it comes to the elbow. So, Geriatric Association in 2001 did a study and they found that the incidence rate of falls for the elderly in community homes was 35 to 40%, which is a large amount. And that doesn't even account for those who are living alone and fall and aren't even able to get help because they're alone. So, also in 2009, the CDC comes out with Healthy People 2020, which are a set of goals that they want to improve public health by 2020. One of them was to reduce the rate of emergency room admissions when it comes to falls by the elderly. So that's why our project is important, because we want to reduce the amount of falls. And reducing the amount of falls has a lot of benefits. When you fall, when you're old, you don't just pop back up like you do now. You hurt yourself a lot of times, they break their hip, and that can have a lot of effects. It will severely impact the rest of their lives. A lot of them don't recover from that. So if we reduce the amount of falls, we should reduce the amount of injuries. We should also reduce the amount of hospital bills associated with the injuries. So there's healthcare benefits when it comes to that. Also, the improved quality of life, because if you're elderly, not only is falling hurt and you're injured, but if you know that you are stronger, you don't have to worry about falling all the time, so they're able to be more active and enjoy what they have left. So we also using young adults as a reference for the elderly, so that way we can use control and compare the elderly and see how their gains compare to basically optimal people at their peak performance. And also, we're gaining new knowledge of neurophysiology, because the weight training we're doing not only increases muscle size, but your neural adaptations and the wiring to your muscles basically changes, and that's where a lot of your strength comes from. So, to understand our project, there are some key terms you need to understand. Muscle interdependency is when you send a signal to one muscle, it recruits other muscles around it to help it. So a lot of people, including myself, I can't bend my pinky finger without moving my ring finger. So that's, I guess it's just me. But that's a case of muscle interdependency. Muscle independence is the opposite of that. You have one signal, so just that muscle and that motor unit will contract, so you get partner muscle control. Your center of balance, there's a point, like you go straight down, there's a point on the floor where your mass is centered, and if you move out of your boundaries, your center of balance moves outside of those boundaries, you fall. So what we're trying to do is improve the ability of the people to keep their center of balance within those boundaries, or if they happen to trip or something, be able to regain their center of balance so that they don't fall. And motor synergy is the ability of your muscles to work together to achieve retaining your muscle, your center of balance. So there's good motor synergy. So if you are pushed, your muscle requires multiple joints and muscles. So if your muscles are able to move independently and together, then they will pull you back. But if you have bad synergy, your body just kind of freaks out, there's nothing to do, and you flail your arms and you fall over. And then, so we have two training regimens. There's individual joints, where we are training each of the joints individually. You have your ankle, that we're doing plantar flexion. Your knee, doing knee extension, and your hip, we're doing hip extension. And those are all 3 separate exercises. Or for the whole leg, we're just doing the leg press. So it works all 3 joints at the same time. So in our literature review, we found that resistance training increases strength, as you would expect it to. But not only that, we found that the most strength increases, the most rapid strength increases come in the first 2 weeks of starting your resistance training. And that comes not from the increase of your muscle size, but from the neural adaptations. So your nerves form new pathways, and you're able to get finer control of your muscles just from your body adapting without the cells even getting bigger. And resistance training reduces falling in the elderly because they're stronger, they have finer muscle control, they're more balanced. And so our mentor, Dr. Shim, has done research in finger training, and they found that if you work your fingers independently, you can reduce muscle interdependency and gain finer control that way. So that leads us to think that the individual training might work better than the whole training.
So this brings us to our research question. To what degree do individual joint and whole leg training improve balance maintenance, recovery through increased motor synergy and muscular strength? Also, what differences can be observed between young and elderly adults? Now, to address these research questions, our team came up with 3 hypotheses. First being, both individual joint training and whole leg training will improve the ability to recover balance through increased muscular strength. This is because we know that each training method, the individual joint training and the whole leg training, uses resistance training to improve strength. Now our second hypothesis, resistance training will improve the ability to recover balance in the elderly more than the young. This is because the elderly has a greater ability to recover from a perturbation getting disrupted from their center of balance because they have a lower baseline strength than the young. And our novel hypothesis, individual joint training will increase the ability to recover balance more than whole leg training through, as Covey said before, the increased motor synergy. So our team used these hypotheses in order to form a methodology. Very simple. We're going to start recruiting from a sample pool, divide them into individual joint training or whole leg training. Each variable group is going to have a 6-week training program where we're going to be testing in the beginning, the interim, and at the end. And ultimately, we're going to collect data that will help us support our hypotheses. So we're pooling 2 groups of subjects here. We're going to take 16 college-age students from the University of Maryland, and aged 18 to 24, and 16 elderly adults above the age of 65. And we're looking for them to have a sedentary lifestyle because if they exercise outside of our training, it could potentially act as a confounding variable to our data. Additionally, we're screening out any participants with neurological disorders because that could potentially act as a confounding variable to the neurophysical adaptations that our training will produce. So, as I said before, we're recruiting students from the university and elderly from the local community outside College Park. And we will be match pairing them into each group according to their sex and BMI. So, for example, say someone like me, you're going to have someone else with my similar attributes and my age and my gender, and we're going to be randomly assigned to the individual training group or the whole leg training group. And of course, subjects will be compensated monetarily and will be entered in for a raffle for their time participating in our study. Training, as Covey said before, we have 2. The whole leg training, where let me demonstrate. All you have to do, the leg press. The individual training has 3 exercises. The ankle plantar flexion, the knee extension,